motor speed control by varying the pulse duty cycle. We know in a pulse width modulation, the duty cycle, if it is varied, the speed of the motor can also vary if it is a DC motor. Here we have the same technology, we have a microcontroller, we have a motor driver IC, and then we have the standard connections, the microcontroller and so on. And then the display where the motor is at 0 speed, now the motor is not running. We got provided some up and down switches. Now when I put a switch of a particular 20% speed, you can see this motor is now started rotating at a very low speed. You can see the movement. Now the movement is at the 20% speed. 20%. This is a geared motor, so what we can see that this speed is slow, only with the view to see that the speed is slow, that this is operating at 20% speed. So for many applications where we need little lesser speed, you can see the position has changed because it is operating at 20% of its rated speed of about say 50 RPM. This is a geared motor. Now if I want to increase the speed, it goes to 40% of its speed. 40% of the speed, and it is because the programming has been done in such a way that the duty cycle will be 40% now. And now I can still increase the speed by 60%. So the speed goes to 60% now. And further the speed goes to 80%, still higher speed. And it can go to even the final speed of 100%. It can also make an arrangement by this arrangement to come down on the speed also. 80, 60, 40 and 20 and up. So this is what is the pulse width modulated speed control.